So this is on your, this is the page you can see of your book only. It is a equation of a line through a given point parallel to a given vector B. ये आपकी बुक में देख लीजिए, it's on page number 468. So when we are given a point A and another vector is vector B, so we have to find the equation of this line OP. How we are going to do that? We had already done in vectors that if a vector is not passing through that point which we need it to pass, we can change its place. That is why we read about free vectors. So we are changing this place of vector B on this line AP. Now this vector B is becoming AP vector. So we will be writing it not as B vector, it will be written as lambda times B vector. Because now these are parallel, you can say, or you can say collinear. So we can write in place of AP vector lambda B vector. Now we have to see in triangle OAP, applying triangle law. So OA plus AP is equal to OP vector. But we have to find the value of this OP vector. So this is becoming OP vector is equal to AP vector plus OA vector. This OA vector is A vector. Means some position will be given of this point like XYZ or X1, Y1, Z1, and some value of B will be given with their DRs, or it can be DCs also. So what will be the formula becoming in this form? R vector is equal to A vector plus lambda times B vector. This is your first formula, right? R vector is equal to A vector plus lambda times B vector. This is the equation of a line passing through a point A and parallel to this vector B vector. Then in the vector form we write it in this way. But what about if we are then asking for the Cartesian form? See, for the Cartesian form, then we will be doing few questions. See, this is the Cartesian form. We had represented this R vector by xi plus yj plus zk. See this? The point A vector we are writing here x1i plus y1j plus z1k. And this B vector we are writing ai plus bj plus ck, where A, B and C are the DRs, direction ratios. And if we put all these values R vector, A vector and B vector in equation 1 means this equation which we had found here. If we substitute it and compare, after substituting and comparing, we are getting x is equal to x1 plus lambda a, y is equal to y1 plus lambda b, and z is equal to z1 plus lambda c. And finding the value of lambda from all these three values, we are getting x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. This is the Cartesian equation of the line. If we are given with DCs, we will be putting it here as L, M and N. If we are given DRs, we will be putting A, B and C. So this is the Cartesian form and this is your vector form, right? Now let us see how the questions will be given. See this, we had done with till question number 3 yesterday. Now here it's question number 4. Find the equation of the line which passes through the point 1, 2, 3. This is your point given which is passing through, means A vector we will be finding from this, and is parallel to the vector 3i plus 2j minus 2k. This is your B vector. So we are writing the position vector of A as I plus 2j plus 3k from this point and parallel to this, right? Passing through this point and parallel to this, simply again substituting it in the given formula. जो हमने अभी पढ़ा था formula, we'll substitute it over here. R vector is equal to A vector plus lambda times B vector. This is just a simple question. So just putting to the formula, if you know how to write it, it's very easy. Just see for the next question. Similar way. Find the equation of the line in vector form and in Cartesian form. We have to find both the forms. Passes through the point with position vector. Already point is not given, position vector is given, and in the direction of this. Every time they will not give that it is parallel to this. They can also say that it is in direction of this, because if we are in same direction means it is a parallel vector. ये देखिए I plus 2j minus k means this is B vector and this is A vector. right? For equation in vector form, r vector is equal to a vector plus lambda times b vector. So this, just substituting these two vectors, this is the required equation of the line in vector form. Now what about the Cartesian form? Cartesian form, we had read, the formula becomes x minus x1 upon a. So the coefficients of b vector, means this is 1, 2 and minus 1. These are our drs. So we have substituted here a, b and c. And what about this x1, y1 and z1? These are the coefficient of this position vector, means 2, minus 1 and 4. So this is becoming x minus 2 upon 1, y minus minus 1. That is why this is becoming y plus 1 upon 2. And this is z minus 4 upon minus 1. So this is your Cartesian form and this was your vector form, right? Now see the next topic. Equation of a line passing through two given points. Now there are 2 points. One is given with x1, y1, z1 and the other is given by x2, y2, z2. Again we have to find the value of this OP vector, which is equivalent to R vector. We have to find the value of this. After using these all triangle law and collinear vectors, we are reaching on this situation that this is R vector is equal to A vector plus lambda times B vector minus A vector. This is also given in your book on page number 470. R vector is equal to A vector plus lambda times B vector minus A vector. This is the A vector, which is the position vector of point OA, and this B vector is position vector of vector OB. And this is your vector form. If we have to find in the Cartesian form, what is the equation becoming? We had already done in the previous formula that x minus x1 upon a, y minus y1 upon b, z minus z1 upon c. And in the previous exercise, we have done that how to find direction ratios when 2 points are given. We always found x2 minus x1 is equal to a, y2 minus y1 is equal to b, and z2 minus z1 is equal to c. So we are writing in the form of 2 points only. But actually these, the denominator is the drs only. So the formula becomes, when 2 points are given in the Cartesian form, x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1 and z minus z1 upon z2 minus z1. So this is the final equation in the Cartesian form. So let's see the question based on this. This is your question number 8. Find the vector and the Cartesian equation of the line passing through the origin. So the first point they had given origin. Origin means we are given x1, y1, z1 is equal to 0, 0 and 0. And the second point is 5, minus 2 and 3. So first we have found the A vector, which will be 0 vector. So it is because the position is 0, 0, 0. And we will be finding the position vector of this B vector also, which is becoming 5i minus 2j plus 3k. The equation of the line in vector form from a point A to and parallel to B vector, we are given with A vector plus lambda times B vector minus A vector. So A vector is 0, so it is just a B vector only. So this is our vector form. And what about the Cartesian form? Since we are given with 1.0, so it is not of much change is there. X minus x1, y1 and z1 is 0, 0, 0. And A, B, C is the same points which is given, because if we subtract 0 from this number, nothing is going to change. So our equation becomes x upon 5, y upon minus 2 is equal to z upon 3. So this is the Cartesian form. Now let us see when it is not given as 0, 0, 0. 2 points are given here. This is your question number 9, 3, minus 2 and minus 5. And this is 3, minus 2 and 6. So these 2 points are given and we have to find the equation in vector and Cartesian form. So first thing, we have to find A vector. So this will become 3i minus 2j minus 5k, right? Now what about B vector? See this B vector. Here they had directly found out what we did in the formula, B vector minus A vector. But here what they are doing, they are finding the directly the value of B vector minus A vector. So they had already found 3 minus 3 minus 2 plus 2 and 6 plus 5. Otherwise, you can directly put into the formula. This is your A vector plus lambda times B vector will become 3i minus 2j plus 6k minus 3i minus 2j minus 5k. You can do like this, or you can find the direction ratios and then you can substitute here. So whatever way you will be doing, you will be getting the same answer. Now in the Cartesian form, x minus x1 upon x2 minus x1. So they had already written here A, B, C because they had specially found out here the direction ratios. So just substituting the values, x minus 3 upon 0, y minus minus 2 which will become y plus 2 upon 0, and z minus of minus 5 means z plus 5 upon 11. So this is your Cartesian form and this is your vector form. Now the next topic is becoming the angle between the given lines. But I think this topic is deleted. This is your next topic, distance between two skew lines. And the shortest distance we'll be studying, distance between two parallel lines and the shortest distance between two lines. These are the topics which are coming in the exam. So this is the distance between two skew lines. Lines in vector form are always given in this form. So this is your r vector is equal to a1 vector plus lambda times b1 vector. And this is the second equation. R vector is equal to a2 vector plus mu times b2 vector. So if we have to find the distance between these two lines, L1 line and L2 line, the formula becomes B1 vector cross B2 vector dot product of A2 vector cross A1 vector. You will be separately finding this cross product B1 cross B2 and then A2 cross A1, and then we will be finding their dot product. And the denominator, it is mod of this, means whatever you will be getting from B1 cross B2 means under root of that the coefficient of I square plus coefficient of j square plus coefficient of k square. This will be the solution if at all you are given in the equation in the vector form between two skew lines. But if the equation is given in the Cartesian form? See here, Cartesian form also I written here. These all are from your book only. This is on page number 475. The shortest distance between the lines. Lines are given by x minus x1 upon a1, y minus y1 upon b1, z minus z1 upon c1, and the second line this. How you will be doing it? This is the formula. x2 minus x1, y2 minus y1 and z2 minus z1. This is in the determinant form. And in the second row, it is a1, b1, c1 and a2, b2, c2. Means we have to solve this determinant separately. And what about the denominator? Denominator, see what it is showing. b1, c2 minus b2, c1 square plus c1, a2 minus c2, a1 whole square plus a1, b2 minus a2, b1 whole square. It's a kind of solving this equation. So they had directly written the formula over here. So this is the formula you have to remember when you will be doing the questions. Then only you will be able to understand how it is coming. Then the next topic is distance between parallel lines. If the two lines are parallel, what is the distance between them? For this, two lines are given. Since they are parallel, their this vector, their drs will be same. So the line is r vector is equal to a1 vector plus lambda times b vector. R vector is equal to a2 vector plus mu times b vector, right? So this is the shown with the help of diagram. This is your a1 vector and this is your a2 vector. Then what is the formula for finding the distance between the two parallel lines? That we have to find the value of this PT, means perpendicular distance between these two parallel lines, because that will be the shortest distance. So it is b vector cross a2 minus a1 vector. Whatever the coordinates will be there of a2, we will be subtracting from that this a1 coordinates upon modulus of b vector. This is also given in your book page number 476. Better to remember this formula directly. Otherwise, the proof is also given. but that is not of any use for you. Only you should know how to apply this formula, how you are going to find out what is B vector given, what is A2 vector, what is A1 vector, and how we can apply this. This is the distance between two parallel lines. Then one more formula is there, distance between shortest distance, that is but just the same, nothing big. And moving back to the question, we'll be not doing this angle question because since it is a deleted syllabus, but you people have to study since you are going for the competitive exams also. See this. Now this is the question. This is your question number 14. Find the shortest distance between the lines. Now this is your question. You have to find the shortest distance, right? So this is your A1 vector plus lambda times B1 vector. And this is your A2 vector plus mu times B2 vector. So you should be able to find out what is A1, what is A2, what is B1, what is B2. And we'll be applying into the formula. This was the formula we have just now read, the shortest distance between these two given lines when they are given in the vector form. So B1 cross B2 will be finding and A2 cross A1 will be finding it out. Writing all the values, A1 vector, B1 vector, A2 vector and B2 vector. First thing we will be finding A2 minus A1 vector. So we had found out here A2 vector minus A1 vector. Subtracting the coefficients of I, coefficients of J and coefficient of K. And then we will be finding B1 cross B2. Always we had told you whenever we are finding for the cross product, we will be finding in the form of determinants. I, J and K. Coefficient of B1 is 1 minus 1 and 1. So 1 minus 1 and 1. Coefficient of B2, 2, 1 and 2. And solving it out. We are getting here minus 3I plus 3K. And finding out the determinant of also this. We are getting 3 root 2. Putting all the values here in this formula. This formula. After putting the values, we are finding the dot product. In dot product, we know I will be multiplied with I, J will be with J and K will be with K. Since here no value of J is there, this is becoming a 0. So it will be minus 3 into 1 plus 3 into minus 2. I am getting here a minus 9 upon 3 root 2. Cancelling, we are getting here 3 upon root 2. Since it is the value of distance, that is why a modulus sign is there, because that will always be a positive value. So this is a becoming 3 upon root 2. Just rationalizing it, I am getting 3 root 2 upon 2 units. So this is the way how to find the distance between, shortest distance between two given lines. This was in the vector form. Now the next question is in Cartesian form. Right? So after watching this Cartesian form, you should be able to recognize what is A1, B1, C1, A2, B2, C2, X1, Y1, Z1 and X2, Y2 and Z2. If at all you are able to recognize this, easily you can solve it. Let us do this.